Hello, and welcome to the Introduction to Exponential Growth and Decay. An equation is considered to be exponential if the variable is an exponent. So one of the things to note is that our geometric equations from the last unit, when you had a sub n equals a sub 1 r to the n minus 1, technically those were considered to be exponential equations because our variable n was the exponent. So we're going to look at a few different things today. Number one is evaluating them, and number two is graphing them. So we have the equation 6 times 2 to the x, and we want to evaluate that for x equals -1, 0, 1, and 2. So we will start by doing f of -1. So again, that means we are going to substitute -1 in place of x. Now, one of the two important things to know here. Number one is you must deal with the exponent first before dealing with the 6. The second thing to remember is any negative exponent will change something from a whole number to a fraction, and the exponent will stay there. So what ends up happening is 2 to the -1 is really 1/2 to the first. And then 6 times 1/2 is going to get us 3. So f of -1 is equal to 3. F of 0. F of 0 means 6 times 2 to the 0. And again, we are going to address the exponent first. And one important thing to remember is that anything raised to the 0 power is 1. So this gets us 6 times 1, which is just 6. So that means f of 0 is 6. F of 1. F of 1 means 6 times 2 to the first, which is going to be 6 times 2, because again, we are doing the exponent first. And then 6 times 2 gets us 12. So f of 1 is equal to 12. And then finally, we get f of 2 would be 6 times 2 to the second. Doing the exponent first, we become 6 times 4, which is 24. So f of 2 is 24. Now we're going to use this information to look at graphing. So when we graph, every single equation for the graph will be in the form of y equals b to the x. So we're going to go through 3 examples of graphs. Our first example is graphing y equals 3 to the x. So the most important thing is we need to make a table first. Our table will always be the x value and then the equation. So x and then 3 to the x. Every time we make a table with exponential graphs, I would suggest you make the same table. -2, -1, 0, 1, and then 2 for the x values. This makes it something pretty easy to graph, and we will be able to see some of the different variations that are happening. So what are we going to start with? Well, 3 to the 0. 3 to the 0, as we said on the last slide, anything to the 0 power becomes 1. So 0 is at 1. Our next one, 3 to the first, well, 3 to the first power is just 3. And then 3 to the second is going to get us 9. Now, working in the other direction with our negative values, we're going to get 3 to the -1. So what does a negative exponent mean again? It means it's changing this to a fraction, so it becomes 1 over 3 to the first, or just 1 over 3. Then 3 to the -2 is going to make this 1 over 3 squared, which becomes 1 over 9. 1 over 9. So what ends up happening is we have some values. We're going to go through and plot these points. Now, if you notice, 9 is a pretty big number, so it's not necessarily going to fit on the graph we have here. So I'm just going to go and label these. We always need to make sure that we label our x and our y values so we see what's going on. And now we can go through and plot some points. So that means we are going to start with the point 0, 1. Then we have the point 1, 3. Then we'd have the point 2, 9, which I am going to draw, but it's off the screen or off the graph. Then we have -1 and 1/3. And then we have -2 and 1/9. So one of the things to realize is that as we get smaller and smaller, the y values continue to get smaller, but they never end up going into the negative direction. Because whenever you take 1/3 to some number, it's always going to be a value that's greater than 0. The second thing to realize is that since this graph is increasing over time, and how do we know it's increasing? Because it's going up from left to right. That means this is considered to be an exponential growth equation. On our next slide, we're going to look at a different graph. So now we are going to graph y equals 1/2 to the x. I'm going to set up the same table of our x and our y value. And again, our y value is 1/2 to the x. And we're going to set up the table for -2, -1, 0, 1, and 2. So now I'm going to do 1/2 to the 0 first. So what happens with 1/2 to the 0? Well, anything raised to the 0 power is 1. We're then going to have 1/2 to the first. Well, when you raise anything to the first power, it doesn't change the value of it. So that means this here is going to be equal to 1/2. Then we're going to have 1/2 to the second. Well, 1/2 to the second means 1/2 times 1/2, which ends up getting us 1/4. So at 2, we're at 1/4. Now let's address 1/2 to the -1. Well, what happens with 1/2 to the -1? Whenever we have a negative exponent, it's going to take our fraction and flip it over. So it's going to become 2/1, and then our exponent changes from a negative to a positive. So that means at -1, we're going to be at +2. We then do the same thing with 1/2 to the -2. That becomes 2/1 to the second, which becomes 2 squared over 1 squared, which is 4/1, or 4. We're now going to take this information and we are going to set up our graph and sketch what we have there as well. So +4, +4, -4, and -4. And let's take a look at what happens with our graph. So when we sketch this, what we're going to end up having is we have this same point at 0, 1. That's going to become critical when we get into some specifics. Then we have the point 1 and 1/2. So it's at 1 and then a little bit, and in between the y value 0 and 1, and then 2 and 1/4. And then 2 or -1 would get us at +2, and -2 would get us to +4. In this case, what ends up happening is the values are getting smaller and smaller. This is decreasing over time. So when something is decreasing over time, that means it is a decay problem because we are getting smaller. So a general form, if our x value is positive, is the following. If the b value is greater than 1, that means you have a growth equation. And that is what was on the previous slide. If our b value is less than 1, that means we're going to have a decay situation, which is what happens on this slide here. However, you need to make sure that you are really looking at the equation. So for our final example, we're going to graph y equals 4 to the -x. If you notice in this case, we now have a negative with our exponent. It does not change our table. Our table would still be x and then 4 to the -x, and then -2, -1, 0, 1, and 2. But now what happens? Well, 4 to the -0, there's no such thing as -0, so that's just 4 to the 0, which gets us 1. Again, everything that starts at 0 goes through 1. Then we're going to have 4 to the -1. Well, 4 to the -1 because the negative is part of the equation and the 1 is the value, is going to become 1 over 4. Then we're going to get 4 to the negative and then a 2. So that means 1 over 4 squared, which is 1 over 16. What just happened? Well, we started off with a whole number that was greater than 1, but then our positive values became the fractions. So what happens with our negative values? 4 negative of negative 1 is going to be 4 raised to the positive 1, which is just 4. And then 4 to the negative of negative 2 is going to get us 4 to the positive 2, which is 16. So what ends up happening in this case? Well, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4, negative 4, negative 4. If we graph what's in the table, we go through the point 0, 1. Every single point has gone through 0, 1. We'll be at 1 and 1/4, 2 and 1/16. We'll be at negative 1 and positive 4, and then negative 2 and positive 16. So what ends up happening? It actually becomes a decay problem. So it becomes very important for you to realize that if the x is negative, if you have a negative x, then a b value of greater than 1 is decay, and a b value of less than 1 becomes growth, because the negative in front switches things around. Hopefully this will help you for the work for today.